Hello everyone, this is Mr. Mohammed Hussain from Madur International School, Grade 10 Geometry teacher. Welcome to week 12, chapter 12, lesson 1, tangent lines. Here are the objectives of the lesson. Identify tangent lines. Use properties of tangent to solve problems. What is tangent line? Let's define it. Tangent line to a circle and the tangent that intersect the end point of the radius on the circle have a special relationship. We have term 12.1, which states that if a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. Look at this figure. This line is tangent to the radius at this point. That means this point is the point of tangency. So, if a line is tangent to a circle at a given point, then a radius drawn to that point will be perpendicular to the line of tangency. Term 12.2 says that if a line in the plane of a circle is perpendicular to radius at its end point on the circle, then the line is tangent to the circle. If a line in the plane of a circle is perpendicular to radius at its end point on the circle, then the line is tangent to the circle itself. On this slide, we are going to verify that if a line is tangent to a circle, then it's perpendicular to the radius drawn to the point of tangency. Look at this blue, light blue line. It is tangent to the circle at point P, so it is perpendicular to even the radius of the circle, which means line M is tangent to circle Q. The circle is named using the center point, if and only if M is perpendicular to QP. And again here, from this circle, this red line segment DB is perpendicular to the radius of this circle, so AB is perpendicular to BD. AB is perpendicular to BD. Theorem 12.3 said that if two tangent segments to a circle share a common end point outside the circle, then the two segments are congruent to each other. Which means, look at this figure. This is a circle and it has radius here, and AC and the BC have a common point at point C, and AC is tangent to this circle at this point A, and the BC is tangent to this circle at point B. So they are sharing point C in common outside of the circle. That means AC is congruent to BC. Now let's see some examples. Example number 1, finding angle measure. What is the value of x in the figure given below? Here is the figure with these givens. So how can you get the value of x? Look at this figure, TPSO. It is four-sided figure. It is four-sided figure with angle T is 90, as PT is tangent to the circle at this point, and PS is also 90, as PS is tangent to the circle at point C, and the central angle is 125 degree, and angle P is X. So we know the fact that the sum of the angles of any four-sided figure is 360. Then angle T plus angle P P plus angle S plus angle O will give you 360. By substituting the given values, angle T is 90, angle P is X, and angle S is 90, and angle O is 125 degree, is equal to 360. Then solving this, or simplifying this sum, 90 plus 90 plus 125 is 305, so X plus 305 is equal to 360. Then solving for X, you will get 55 degree. Example number 2 is finding distance. The Riyadh TV tower, Saudi Arabia, is 170 meters high above ground level. About how far is it from the TV tower to the horizon, taking the radius of Earth 6,400 kilometers? Assume this is the situation. Assume this model's Earth, and this is the TV tower. Then drawing these lines, look at this. This is the radius of the Earth, and this is the height of the TV tower. So we need to find the distance from the top of the tower to the horizon, which means if someone look around from this point, for how long or for how far can he observe things, or the end of the location, which means horizon. Using Pythagorean theorem, this is right angle triangle, radius of Earth square plus height of the TV, of course in kilometer, you need to change into kilometer. It was given 170 meters, is equal to x squared. This is the hypotenuse. So 0.17 plus 6,400 squared plus 6,400 squared equal to x squared. So simplifying this, it will give you this much equal to x squared. Then taking the square root of this value, x will be 6,400.17 kilometer, which is about 6.4 kilometer. Example number 3 is about finding the radius. What is the radius of a circle shown below? Here is a circle, and with these givens. Okay, this is x, this is 12, and this is 8. So how can you find the radius of this circle? Look at this line. This line is tangent to this circle at this point, and it's perpendicular to the radius of the circle. This is the central point, so this is also x. So you can use Pythagorean theorem, as this is right angle triangle, and assuming this is the hypotenuse. The length of the hypotenuse is x plus 8. One leg is x and the other leg is 12. So x squared plus 12 squared is equals to x plus 8 squared. X squared plus 144, when you simplify this, equals, this is factoring, I mean you can use FOIL method, x squared plus 16x plus 64. So collecting like terms, you can minus this or cancel x squared by x squared. 144 is equals to 16x plus 64. So taking 64 to the other side, 80 is equal to 16x, and dividing both sides by 16, x is equal to 5. Example number 4 is about identifying a tangent line. Is AB tangent to a circle? Is the circle, and the situation is represented here. Okay, look at this. AB, is it tangent to this circle? This is the radius 5, and this length is 13, this is 12. How can you verify that this line is tangent to the circle or not? If AB is tangent to the circle at this point, it should be perpendicular to the radius of the circle, which means angle A must be 90. If angle A is 90, then you can apply a Pythagorean theorem to verify 5 squared plus 12 squared is equal to 30 squared. If this is right angle triangle, which means if angle A is right angle triangle, this is true that 5 squared plus 12 squared must be equal to 13 squared. Then 25 plus 144 equals 169, which means this is equal to this side. So your answer is yes, AB is tangent to the circle at point A and angle A is 90 because the Pythagorean theorem is verified. Example number 5 is about circles inscribed in a polygon. What is the perimeter of a triangle in the following figure? Here is the figure with the given lengths. This is 5, this is 7, and this is 4 centimeters. Then how can you find the perimeter of triangle ABC? While this length is 5, and from this point to this point is 4, and this is 7. But remember that any two tangent lines to a circle which have the same common point outside of the circle are congruent, which means this is 5, this is 5, and this is 4, this is also 4 because C is common point. This is 7, this is also 7 because B is common point. Then from theorem 12.3, if two tangent lines to a circle share common point outside the circle, then they are congruent, which means 5 plus 5, 7 plus 7 plus 4 plus 4 will give you 32 centimeters. Finally, dear students, don't forget to practice on exercise from your textbook and workbook related to this lesson, and thank you.